Good afternoon, everyone. Back. Now we start with a hands-on with QualX. So first, just for who didn't download the program, I just want to introduce it. So to download the program, you just have to type the website of CNR and then to choose software and then QualX. So when you click on download, you have required to register yourself with your details, and then at the end you will be allowed to download the program and also the POW code, the database. So you choose hit, and then you can download it. I remind you that QualX it's only for Windows version, so it works only for Windows. And at the end, you can download POW code and POW code INO. So there are two different databases, one for inorganic compounds, POW code INO, and the other one, POW code for organic ones. So it takes a while to download it because the database is a big file. But at the end, you will have the software and you can start to install it, and also the database install it. So I'm sorry because I'm left hands and I can use it. Okay, in this afternoon, we will manage 3 different examples and we will run the program with these 3 examples. You already have the data, and these are example 1, CPD 2, and mix 5. So these are different mixture that we use to test the program and to try to be confident with the program. Okay, sorry. When you have installed the program, you have to click twice on the icon, and then a window like this will appear on your desktop. So in File, you can choose the data that you want to load. So if you just click on New, you have a new run working. If you import the diffraction pattern, you import your diffraction pattern and open project with the extension QualX. It's a project that is already existent. And if you want to view file or output, you can choose it and then save when you have the possibility. Or also you can just to view some recent file or recent project. So in this case, we just import the diffraction pattern. So I'm already inside a folder with the examples, but you can choose where you have your data and then click on them. The program is able to read the data that has extension of DAT, XY, XYE, or also ASCII profile, the other ASCII profile to columns to theta intensity, the Jesus format, the SIF powder data, and XYE. So the 3 examples that we have are files with extension of DAT. So I choose the first one, example 1, and I open it. So now is the time to decide the wavelength. Usually this information is known and you choose the wavelength that you are using. So is a default choice the lambda 1.54060, or you can choose the one that are you using when you measure your sample, your pattern. And say, okay. So at this time appeared our diffraction pattern. This is an ideal diffraction pattern because, as we've seen, the peaks are very nice, and also we don't have really much background. But in pattern, we can decide to reduce the range. If we have a big range of 2 theta, for example, from 2 theta at 100, I don't see any other peaks, then I can decide to cut. And here I can decide to cut from the beginning or from the end. So I'm fine with this at the moment. And say still on pattern, I can create a background. So if I create a background, we see all these red dots. And I can also decide in background options to add or remove the dots. I can decide the background type if I want to choose a cubic spline, a polynomial, a Bezier spline, and in this case, it's fine, the polynomial. This is usually the default choice, or I can add points with a left click or delete points with a right click. And say, okay. And now I have the background chosen. I have to remove it as still in pattern. I can subtract the background. And now the pattern is fine. And the next steps is a peak search. So the programs just gives our peaks because it's reducing our diffraction powder pattern in the high values. And from each peaks, I have a line corresponding. But if I'm not satisfied on that in pattern, I can choose peak search options. And also in this case, I can add or remove peaks. For example, if here I say a new peak, I can add it, and then with the left click, I can remove it. And I can do this each time I need to do it. And then when, for me, the pattern is fine with the peaks, then I can say, okay. I can also decide to increase the threshold on intensity or the sensitive. In this case, in the first case, I see something is appearing or disappearing, and also in the sensitivity. And I can say, okay, if I want to change something, or I just now cancel because I was fine. And now I can have a look of the peak list. In the right part, I see the 2 theta that I have chosen and the corresponding intensities. And still in patterns, I can decide to delete peaks, but I can just use using a right click when I'm in peak search options, or I have also the possibility to import peaks from a file. And here I can also, if I didn't do at the beginning, I can choose the radiation wavelength. And also I can remove decay alpha 2 stripping and the 0-point correction smoothing. So when everything is fine, I can start my search. First, to start my search, I have to be sure that databases is in my folder. So when you download the PAL code, you have to extract all the files and put in a folder inside the QualX. So we are in program files and then QualX, and then we have the code and code HINO. So if it's the first time that you're using the program in you have to add your database, and then you choose it here, and then you say open, and then you will have your database installed. So I'm using code HINO because this sample contains inorganic compounds, and say closed. And in search, with a search match, the program will run his search and gives us the possible phases inside the sample and they are ranked according to a figured merit, as here is reported. So in this, now it appears the name, the compound name, the card number, the formula of the first of the chemical formula of our compound, the peak position, the intensity, the scale, the figured merit, and also we have information of semi-quantitative. Just to be reliable, the semi-quantitative analysis, I have to accept more than one phase. To accept the phase, I have to click on Accept Selected Phase. So some peaks are justified from the lanthanum hexaboride, but still there are some other peaks that need to be justified. So this means that our sample contains not only lanthanum hexaboride, but maybe there's something else. So if I want to see the card belonging to the lanthanum hexaboride, I have to click here on this icon, and then we'll open the corresponding card. We have the code zip file, the name, the mineral name, and all the information or the details belonging to the lanthanum hexaboride. Actually, the second phase that the programs gives me with the second bigger figured merit is silicon. And actually, this sample contains lanthanum hexaboride, silicon, and corundum. And if I accept it, on the third position, I have corundum or aluminum oxide. And as you see, we have more different cards belonging to aluminum hexaboride. This is because in our database, there are stored more than one card belonging just to one phase. And if I want to have the information about the aluminum oxide, I can click on it and then to see the card corresponding. So I have also the information if it's a calculated pattern or if there are data coming from synchrotron or something like that. These other icons just give me the possibility to change the color of our face or to scale. Or if I know the number of the card that I want to look for, I just have to write the number and then I will appear the card if the card is inside the database. So another possibility is to sort the card, clicking on the compound name. I can sort on them. Oh, sorry. I can sort the cards by alphabetic chemical formula. And on search, I have also the possibility to use the restraints. So the restraints will sorry. Okay. 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 For example, I just use the restraints. Okay, for example, I just use a number of the card 0023 0448, and then I say find And sorry, I don't know. I just have to launch again the program. Okay, I import the diffraction pattern, the example, and then open and say okay, and then create background and subtract background, and a pick search and search match. And I can also use restraints. Don't know what happens with my, okay, it takes just a while. For example, I want all the, I can use the composition and I can choose here which element I want to look for, or I can use the subtitles because I have also this possibility, or use the chemical name, for example, corundum, and say load cards. And of course, you can use load cards or load cards and merge. And actually, I have all the cards that take the name corundum. So we have a lot of cards, some of them with, mostly of them with a calculated pattern. So at the end of performing our program, at the end of the qualitative, we have the composition of the sample, that is corundum, lanthanum hexaboride, and silicon. And also with this button, we can open a new folder, a new card. We can open a new one, and here we can open one that already we have. With the save button, we can save what we are doing, and with this, we can enlarge a part of the powder diffraction pattern, and also we can go up and down to rescale it, and we want to resize it. So this is the first example, and here we have all the information of semi-quantitative analysis. If I just search match and I accept the first one, and then the second one, and then the corundum, we have semi-quantitative information, and they are more or less readable with what the sample contains. And here, with the color, with the different color, we have the different cards belonging to the three different phases. So we have the 2 theta and the intensities belonging to each phases. And of course, if all the peaks are justified, at the end, we have the whole composition of our mixture. I start with the second and file. You import the diffraction pattern, and we choose the second, that is CPD2. And then you open it. And I'm sorry, you cannot hear me. Yeah, it's because someone told me that I have to be far away.
Started.
Okay. Okay. And the wavelength is still the same. But here you see something that is maybe wrong. You see the signal is quite big. Sure? Right? Yeah, it's a case of preferred orientation. So in this case, first we create, as before, the background, and we remove it. And also, we just add a K alpha 2 stripping. So Now, what have you seen? That's a kind of balance, I would say. And if I just pick search, I have all the picks. So if I just enlarge it, I have one line from one picks, and I say, okay. This is for all the pattern. And here still I have my 2 theta and G intensities. And here I can decide to work again in coding code INO or code on PDF2. In this case, these are data of inorganic compounds still in this case. So the code INO is fine still. So I don't have to change it. And then I search match. So at the end of search match, I have our list of the possible phases ranked according to a figurate merit. So at the first position, I have zinc oxide, and I accept it. And calcium chloride, and you can zoom it and to see that some picks are justified from the first two phases, but some others still are our difference. So the black lines are the difference. So I need to yeah. That's fine. Okay. And we see here the picks, and we can. So as we see, the black lines are quite a lot. So actually, the problem could be that there's still something inside our sample that is not justified, and I have to look for carefully. So if I just click on corundum, the line is getting light blue, and 8.1 is this one, the phases, and these are the peaks belonging to the corundum. So actually, I should say that corundum is inside. And if I want to understand better, I can open the card of corundum and to see each picks, the 2 theta and the intensities, the corresponding intensities. And I have at 2 theta 35 our bigger intensity. And so I have a look on 35. Mm-hmm. So around 35, I see the biggest line of corundum. So all the others should be smaller. But still something is left inside. And I have zinc oxide. I'm not choosing the other one because already have present corundum. Okay, and corundum. And the last phase is inside is a brucite. So I can just do the same things. I open the card corresponding to brucite. Mm-hmm. Okay, and here I just want to check. Here, brucite is here, and I see a big 37. So I just close it and I check it. Around 37, there's something moving here. And this is the semi-quantitative analysis of the all phases inside our sample. So this is a semi-quantitative, and as we've seen, we have a huge number of phases, so is quite okay, but not really correct. Sorry, I can't hear you very well.
The semi-quantitative analysis, the volume or conflict weight
percent.
Yeah, but the volume or weight?
Weight percent.
Weight.
Yeah. Any other questions for this example? Sorry. You mean how can I identify the black line? Yeah, the black line is just the difference, and I have to look carefully here. It seems that something is missed because we have a difference, but instead this peaks corresponds to the one justified on the fees that I have already accepted, and also this one, and also this one. Okay. I move on to the third example. Okay, the last example is a quite complicated mixture. As the name is mixed. I open and I say, okay. So, as before, I have first to create a background and to check if everything is fine. And actually, and then I subtract it.
Yes.
Sorry?
Is it possible to adjust the background?
Yeah, you want to see again? Yeah.
I think the question was, can you modify the background?
Yeah, sure. Just tell me what you want to do. I will do for you. You want to... Yeah, sure. You have to add point. You have to add one by one anyway. Yeah.
You do that with mouse. Yeah.
Yeah, I don't have my mouse.
Oh, I see.
Okay.
Yeah, sorry.
You just had here, for example, or other point here, and other point here. You mean this? Okay. Or other point here. Sorry, I used the left one and I remove it. Okay. And then, okay. You can do it every time you want. So up, you are more or less sure that for you it's fine.
Sorry, I have a question regarding the background after 100 degrees to theta, because it seems like the program has picked up peaks as well.
Yeah.
And if you subtract now, then you subtract into the reflections, no?
Removing it. And okay.
Right.
And you can also hear and hear. Of course, you can add or remove as you prefer and say okay. And now subtract it. It's quite okay. And now a pick search. You can do the same with the picks. So if you want, you can add or remove picks. Still with pick search options, I click on it. For example, if I want to remove it, or if I want to add it, and you can also add here or here and say okay, and I just enlarge it and then a search match. And here we observed some peaks that are belonged with lanthanum hexaboride, but many others still are there. And then I can add zinc oxide. Sorry? And corundum. And the last one is calcite. And then to check if to each peak I have one phases belonged. And to check really carefully. Because also here there's a little bit of shift of the peaks, and that of course these peaks belong to the phase of calcite.